Hello everyone, this is Kalpana here. In this video, we are going to see a problem from partial differential equation. So let's get going. Problem. Form the partial differential equation by eliminating the arbitrary constants a and b from z equal to 1 by 2 into square root of x plus a plus square root of y plus b. We are given an equation which involves arbitrary constants, and by eliminating the arbitrary constants from z equal to 1 by 2 into square root of x plus a plus square root of y plus b, we are asked to form a partial differential equation. So let's see that. Given z equal to 1 by 2 times square root of x plus a plus square root of y plus b, consider as some equation 1. Now partially differentiate 1 with respect to x. Okay, first we'll see the detailed explanation and then we'll go for the shortcut. Apply dou by dou x on both sides of 1. This gives us dou z by dou x. Here z is a function of x and y. Okay. Where x and y are independent variables. Is equal to constant 1 by 2 into partial derivative of the first term, which contains x, plus partial derivative of the second term, which contains constants. Since we are partially differentiating 1 with respect to x, so we'll treat y as constant here. So here we have constant. Now let's use the notation dou z by dou x equal to p and replace the LHS part by p. We'll get p equal to 1 by 2 into partial derivative of square root of x plus a. Since we know that derivative of square root of x is 1 by 2 root x, right? But in place of x we are having x plus a, so you'll get 1 by 2 root x plus a into inner derivative, that is dou by dou x of x plus a, plus partial derivative of a constant with respect to x is 0. Okay, this gives us p equal to 1 by 4 into 1 by square root of x plus a into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0, which gives us p equal to 1 by 4 root x plus a, or we can write this as square root of x plus a equal to 1 by 4p. Okay, we'll just take this or bring this square root of x plus a to LHS and take this p to RHS, and we'll get square root of x plus a equal to 4p. Okay, we got p equal to 1 by 4 into square root of x plus a, right? We can split this as 1 by 4 into 1 by square root of x plus a otherwise. Okay, or simply you can write this as p equal to 1 by 4 by square root of x plus a, right? Now take this square root of x plus a to LHS, bring this p to RHS, you'll get, right, which gives 1 by 4p. Okay, or take this square root of x plus a to LHS, you'll get square root of x plus a, and bring this p to RHS, you'll get 1 by 4 into 1 by p, which gives us square root of x plus a equal to 1 by 4p. Consider as some equation 2. Okay. Now partially differentiate 1 with respect to y. Apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to 1 by 2 into partial derivative of square root of x plus a plus square root of y plus b. Since we have a notation dou z by dou y equal to q, so let's replace dou z by dou y by q. We'll get q equal to 1 by 2 into, here we are partially differentiating something with respect to y, so we'll treat x as constant. So we'll get partial derivative of square root of x plus a is constant, which is 0. Since x is constant, so partial derivative of a constant with respect to y is 0. Okay. First we'll write partial derivative of first term plus partial derivative of second term. Which gives us q equal to 1 by 2 into partial derivative of a constant with respect to y is 0 plus partial derivative of square root of y plus b. Since we know the square root of, derivative of square root of x is 1 by 2 root x, so we can write this as 1 by 2 root y plus b into inner derivative, partial derivative of y plus b. Okay, this gives us q equal to 1 by 2 into 1 by 2 root 2 into square root of y plus b into partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0. Okay, or you can just write one more step here. Dou by dou y of y plus dou by dou y of constant b. Okay, we'll write it again. Then q equal to 1 by 2 into 1 by 2 root y plus b into partial derivative of y plus partial derivative of b. It gives us q equal to 1 by 2 into 1 by 2 root y plus b gives 1 by 4 2 into square root of b y plus b into partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0, which gives us, I'll take this for 2 LHS, so I'll get 4q equal to 1 by square root of y plus b, or we can just write, okay, from this we'll get 4q equal to 1 by square root of y plus b, which gives us square root of y plus b equal to 1 by 4q. Consider as sum equation 3. Now observe 1, 2 and 3. So we can replace square root of x plus a by using 2, and square root of y plus b can be replaced using 3, so that the arbitrary constants a and b gets eliminated, right? So let's substitute 2 and 3 in 1. We have 1 z equal to 1 by 2 into square root of x plus a plus square root of y plus b. Substitute 2 and 3 in 1. We get z equal to 1 by 2 into Since square root of x plus a equal to 1 by 4p, so replace it by 1 by 4p, plus square root of y plus b can be replaced by 1 by 4q. Okay, now take 1 by 4 common from these two terms. We'll get into 1 by 4 into 1 plus p plus 1 plus q. Simplify 1 by p plus 1 by q. Okay, by taking 1 by 4 common, you'll get 1 by p plus 1 by q, right? Now let's simplify this. LCM of p and q. The numerator, you'll get q. Just make a cross multiplication, otherwise you'll get q plus p. Okay, this gives us 1 by 2 4s are 8 into q plus p by pq, right? Or we can write this as q plus p by 8pq, right? So we got z equal to q plus p by 8pq here. Then okay, I'll write z equal to q plus p or p plus q by 8 plus q. Now I'll bring this to LHS, which will get 8pqz equal to p plus q, or we can write this as p plus q equal to 8pqz, which is the required partial differential equation. See, it does not involve any arbitrary constants. Is the required partial differential equation. Now let's see the same problem by reducing the number of steps. Given z equal to 1 by 2 into square root of x plus a plus square root of y plus b, we have considered as equation number 1. Now let's partially differentiate it with respect to y. Sorry, with respect to x. So we'll get dou z by dou x equal to 1 by 2 into partial derivative of x, square root of x plus a is 1 by 2 square root of x plus a into inner derivative. Partial derivative of x with respect to x is 1 plus partial derivative of constant with respect to x is 0 plus partial derivative of constant with respect to x is 0. Since we are partially differentiating the term with respect to x, so we'll read y as constant. Okay. Since we have a notation dou z by dou x equal to p, so let's replace dou z by dou x by p. You'll get p equal to 1 by 4 into square root of x plus a. Now take this 4 to LHS, you'll get 4p equal to 1 by square root of x plus a, or we can write this as square root of x plus a equal to 1 by 4p. Just take this to, bring this to LHS and take this to RHS, so you'll get square root of x plus a equal to 1 by 4p. Consider as some equation 2. Now partially differentiate 1 with respect to y. We'll get dou z by dou y. Here we are partially differentiating 1 with respect to y, so we'll treat x as constant. Okay, we'll get 1 by 2 into partial derivative of constant with respect to y is 0 plus partial derivative of square root of y plus b with respect to y is 1 by 2 root y plus b into inner derivative, that is partial derivative of y plus b. Partial derivative of y with respect to y is 1 plus partial derivative of b with respect to y is 0, right? This gives us, here we need to apply, we use notation dou z by dou y equal to q. In order to replace this by q, you'll get q equal to 1 by 2 into 1 by 2 is 4, that is 1 by 4 into square root of y plus b, right? See, 1 plus 0 is 1, so you'll get 1 by 2 into 1 by 2 into square root of 1 plus b, right, which gives 1 by 4 into square root of 1 plus b. right? Or we can write this as, take this 4 or bring this 4 to LHS, you'll get 4q equal to 1 by square root of y plus b, or you'll get square root of y plus b equal to 1 by 4q. Consider it as some equation number 3. Now observe 1, 2 and 3. See, you got the same thing. Nothing has changed here. By observing 1, 2 and 3, we can ensure that by substituting 2 and 3 in 1, the arbitrary constants a, b gets eliminated, right? So let's substitute 2 and 3 in 1. We have 1 z equal to 1 by 2 into square root of x plus a plus square root of y plus b. Substitute 2 and 3 in 1. We get z equal to 1 by 2 into square root of x plus a 1 by 4p plus square root of y plus b 1 by 4q. Okay, by 2, and we got this by 3. Now take 1 by 4 common from these two terms. We'll get 1 by 4 times 1 by p plus 1 by q. Okay, which gives us 1 by 8 into. Now simplify 1 by p plus 1 by q. Take the LCM of p and q. You'll get q plus p by pq. Right? Or we can write this as 8 equal to p plus q by 8pq. Now bring this to LHS, you'll get 8pqz equal to p plus q, or p plus q equal to 8pqz, which is the required partial differential equation, right? Therefore p plus q equal to 8pqz is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.